Hey everybody. I'm Ken underscore Wheeler on Twitter. Um, and I have not historically been kind to the web. Um, been doing this for probably about 15 years. And I've had my complaints along the way. At one point, I've tried to make app browsers. I've given a lot of talks on basically that there's two kinds of things that we're doing on the internet. We're doing websites that you read, like news or just like information, and then somewhere along the way, somebody decided that we should build apps in the browser. JavaScript came along and that made it a bit more possible. um, but compared to apps that you see on other platforms, they're a little bit less polished. It's a platform that's a little less suitable for application development. So a big theme that I've pushed for a number of years is making browsers more capable for developing real applications. So the web has its problems. If you've ever actually built anything for it. Uh, one notable thing, if you're a web developer, is dealing with select dropdowns, right? Um, I can't think of a time that a designer has handed me a design that had a regular select dropdown in it, without wanting it styled or creating a different one. Um, Also, things like list views. This is at the end of the day, when you look at applications, whether it's Facebook, whether it's Twitter, Instagram, any social thing that you're looking at, it's all just lists of things. um, and what separates a lot of the native apps from the web apps is that native apps have virtualized list views, um, whereas the web does not have a virtualized list view, but it's certainly coming. And the one that gets me the most is the inherent single threadedness of your web page. So other apps will do things like, they'll have threads and they'll be able to offload the work. Until recently, and actually still most of the time, most of the performance problems that you see, is because everything, absolutely everything, is occurring on the main thread, the one main thread. Um, However, after years of talking a crazy bunch of crap about the web, um, it's actually, in my opinion, getting better. There's some features that are that have been out, right, that don't get as much play as they should. There's some new features coming in, that's making it much more suitable to develop applications in. Um, so that's on most browsers, and when I originally gave this presentation, no, I mean, I guess it still holds true for Safari and mobile Safari, but I know that they've made some interesting hires lately, and I'm interested to see what they do. It seems like, um, a better web is on their plate, so to say. So the web itself, early on, wasn't designed as an application platform at all, right? It was designed as, a thing for sharing research documents, right? So it's really just documents. You think about, document object model, etc. um, it's that's what it was supposed to be. You might not like it, but this is what peak performance looks like. it's that's all the web used to all just look like this. And in the ideal use case, you're looking at it. So then something happened. We had the web like that for a while, and then Flash came along. And some people hate Flash, some people love it. I worked in it extensively early on, and I loved it. But the one thing that Flash did was it let you do rich experiences in the browser. So suddenly you were able to have decent quality games in the browser. Suddenly, if you're making a website for a restaurant in Flash, right, you have all the things animated, and and fun, and there were sounds and noises. It was like a NASA console or something like that. So people realized that you could make rich apps on the web. So then everyone was having a good time building their rich apps for the web, and Flash pretty much got killed when the iPhone came out. And I don't want to point fingers, but maybe it was cutting into some competition. I don't know. We'll never know. But it went away. But what came next was a bunch of people running to CSS3 and HTML5, which had come out, which gave you new capabilities. Now, most of these capabilities were centered around making, better document style websites and not apps. Some of them were app centric. But along with this, right, you started to see this surge of use in things like jQuery, right? Like people came from Flash and they were used to animating things and doing all this fancy business. And then it got taken away. So you started to see people use, jQuery and Scriptaculous and everything like that to get those animations and stuff back. And that's way before any of the modern animation tooling that we have today. And it was a little bit of hope that all right, we're all switching back to HTML and CSS and JavaScript, but pretty soon it's gonna be crazy. It's gonna be the web itself will backfill that need. And it largely didn't. I think a Flash website on an old computer 10 years ago, was it 10 years ago? Maybe it was 10 years ago. Probably got better animation performance than you see a lot of the time today. So what happened was when the browsers didn't really get that much better or provide as much accoutrements for application development, you started to see these problems get solved in userland. And then we entered what I call the era of tools. So you started seeing things like Babel and Sass and React and all kinds of different things to essentially solve a lot of the problems in user space. And as we know, not only has it increased the complexity of front end development and increased the learning curve, but a lot of the time it's actually made a lot of our stuff a lot slower. These tools are not easy to use, generally speaking, and when misused, it's worse than if you hadn't used them at all. So while this was happening, while everyone's this is the new framework or this is the new thing, and we're having fun with that, the platform, right, the web, the browser groups, they've actually been coming up with some really cool features that I think some of them were largely missed because of the excitement of user space tools. So I'm here today to talk about some things that they've come out with that are fun if you're doing application development. Some of this is cross applicable if you're just doing regular web development, and a lot of these features will let you build better apps and better sites than you previously were able to. I've traditionally, at least for the recent history, been really into React, but probably over the last year or two, I've gone back when I can and bail out and use just regular platform features because it's much faster. React, as we all know, is bad for really simple websites, right? There's no reason to use it on really simple things that aren't a great target for it. But one thing that I don't think gets talked about a lot is that for really complex things, it's not that great either. There's a middle ground where it performs really well. For super complex things, you're most of the time better off going back to platform features because it'll be a lot faster. So let's hop into it. The first thing that I don't see get as much play as it should, but is an extraordinarily powerful feature, is web workers. What they do is they essentially let you run your scripts on background threads. It brings a degree of threading to the web. The different workers, they have networking capabilities. They can receive data from the main thread through a messaging model, and they can send data to the main thread with those messages. Right. So if we look at this, is my cursor here. If we look at this little diagram, right, you create a worker, and in here you have these event handlers, right, that send these messages through post message back and forth. So you can offload um, operations to take place in here and then send back what you need. Right. So let's take a look at how that works. So you check if workers are in play, then you create a new worker, right, and then you just set up this listener here, where when you get a message, right, you console log it, message with the data, and you can call the post message for the actual worker itself here, right? You could say on message, right? Let ID equals e.data. Let's say we could fetch something, for example, right? This would be like a fetch that we do. And then we can post message it back. So this would be like a fetch. Normally you wouldn't just put a fetch in a worker, but just an example of that volley back and forth. So if you're not just going to throw fetches in there, what do you do with them? So when you want to use a worker is if you have a CPU intensive operation that's blocking the main thread. You'll see it if you have anything animating, or if you have anything that's slower to respond. That's CPU load, right? So any large operation, if it takes place on the main thread is also your renderer. So you're liable to lock up your app. So by taking CPU intensive things and putting them in a worker, you free up the main thread to just keep running the UI show, so to say. So really it just keeps your app interactive. I know if you look at like a lot of like the Google performance recommendations, they focus on time to interactive. So this is like how long until I can interact with the site. And that's one thing, but I'm a big fan of keeping the app interactive, and this is a great way to do that. I'm just gonna well, no, I'm not gonna show that. So let's talk about UI, right? Because workers they're great for the data portion, right? And offloading your CPU intense operations, right, to there. But the UI, what about intense UI stuff? So there's a feature called Offscreen Canvas. If you're familiar with regular Canvas, it's basically that, but it can be run in a worker and kind of like double buffered, right? So it's a canvas that's fully detached from the DOM. You can run it in a worker, so you can thread it out. You can use it even when there's not DOM, and what it allows you to create is uninterruptible user interface. So even if there is blockage on the main thread, an off-screen canvas will not block. I wish I could say the same about the DOM itself, but we're not there yet. Right now, a canvas is the only UI that can kind of be segmented and do its own thing in a thready kind of way. So the way that you do this is it's actually kind of like a two canvas sort of setup. You find the canvas that you want to be like your host, and you call transfer control to off screen on it. And then if you have a worker, right, you can send in the canvas itself as a transferable, right? So it kind of has like a reference to that. And then in your worker, nice typo. But yeah, you get the message, and you can set the canvas in here. This would just be like a regular animation loop taking place here. And you just draw stuff in the worker, and it'll draw to the canvas that's in your DOM, but all the drawing operations of it are on another thread, which means that if you do anything in the main thread, it won't get interrupted. So I am going to show you a quick example of that. Here on the left, we have a regular canvas, and on the right, we have an off-screen canvas. And I'll just show you the stuff here. Yep. So in our code, I'll just show you the HTML real quick. We have these two canvases, frame and frame 2, right? And then in here, right, I have a silly contrived method here called calculate primes, which just takes up a whole lot of memory. And in here, you have our regular canvas, which is this one, the frame canvas, and we go through and we can do our drawing, right? This just draws the red square. So that's the one on the left. If we go into the worker here, it's largely the same code, right? Except this one is an off-screen canvas that has been sent to the worker, right? So we come here, when you click your main thread button, it'll call calculate primes, and it interrupts the regular canvas, but this one keeps going. While we're here, we can look at the web worker with a different example. If you were to just call it on the main thread, it'll interrupt it. Whereas if you call it on the worker thread, right, it's being called and it's not interrupting it. So that's an easy perf win. So there's a thing that I wrote called React Blazing. So this uses off-screen canvas and essentially re-implements the DOM with a React Native API. If we come on over here and look at our setup here, if you've ever written React Native, this might look kind of familiar to you. You're using the object style CSS here. I have components like hoverable with view, and then app, and then you have, it's written pretty much like React. The difference is that this is 100% canvas. So in here, I can use React Spring, just import it just like anything else. I can have on-click events on these views, text recalculation. It's written exactly the way that you would write maybe React Native Web. But this is all canvas. And this being reasonably fast, I chalk up mostly to off-screen canvas and creative use of workers. Good times. Okay. Whoop. So the next thing I want to talk about was worklets. And outside of workers and off-screen canvas, worklets are some of the most exciting stuff going on right now. Lightweight, kind of like purpose-built versions of web workers. And you can run JavaScript or WASM, and it'll let you do really interesting things. Each one of them has a particular purpose, right? You have things like the audio worklet for audio processing, or paint worklet, or animation worklet, or layout worklet. There's a thing called Houdini that I'm going to show. So it's a collection of browser APIs that basically change CSS forever, and they make use of these worklets. It essentially lets the styling and layout process of your browser be extensible, and lets you hook into it and write things like custom properties, and for the most part extend CSS. It's composed of worklets, custom properties, your paint API, your typed object model, the animation API, and the layout API. I just want to run through a paint worklet real quick because this is really cool. Even if you saw the stuff that I was just showing and you said to yourself, Canvas, all right, that's cool, whatever. But I'm probably not going to use Canvas. I don't really have a reason to use Canvas. Now you do. So say here, right, you have my element, and in here you have paint here. You're saying paint Chuck Norris, right? This is a valid property for background image, right? So in your JavaScript, you would add your worklet that you've written, your paint worklet. You'd add the module. Inside of there, you can register a paint worklet with its name, right? And then you have a class inside of here at the paint method. And this is actual Canvas code, right? It gives you a Canvas context. It gives you the size, props and arguments that you might take there. And then, based upon what was supplied, you can go in here and actually write Canvas code. I'm just going to hop back for a second. Oop. So you can have these custom properties and values in CSS, but they're implemented using Canvas drawing, which is bananas. You can do really crazy things. And if you say, this just makes Chuck Norris your background image, but I'm sure you could do I've seen a lot of people do really cool things with like borders and stuff like that. It's a hoot. So I'm a musician and I love messing around with web audio. It's one of my favorite things. And this was a very exciting one for me in Audio Worklet. Up until now, the web audio API, it was good, but it was very difficult to do anything real median, right? Because you're CPU bound and among other things. But Audio Worklet lets you do some pretty crazy stuff. So it's a worklet for processing audio, right? Digital signal processing. And it replaces what you would previously use a script processor node for in the web audio API. So ideally, right, it helps relieve that main thread pressure. I've seen a lot of people put like effects and stuff in here. And you can use WASM in there, which lets you do some really interesting things. WASM, anytime you're dealing with streams and numbers, WASM knocks it out of the park. And digital audio processing is pretty much all streams and numbers. So just like if you're going to do anything in the web audio API, right, you create a new audio context. And then in here, audio context, audio worklet, you do an add module, much like the paint worklet with your worklet. And then once it's registered, right, you create your new worklet here with that context, name it, and then you can connect it to the audio context destination. Normally in web audio, if you've used it, if you haven't, then audio context destination is like your speaker output. It's like where if you made like a sound or something like that, that's where you send it to, right? So you're connecting this audio worklet to there. So inside of there, right, you can have this class called my worklet processor, right? And then you have this process method in here that takes inputs, outputs, and parameters. And this is really just a bunch of numbers. I have a whole nother talk about how this works. But when processing audio data, you're really just getting streams of numbers. And then multiplying them or dividing them, doing all kinds of stuff, and it will process them over time. Sometimes they're stateful, sometimes they're not. But this gives you a lot of power in order to operate on that stream of audio data, right? So here, right, you might have your input and your output right there, and then you have that you have channels, right? And then for each of the channels, right, you would go and pipe it to the output and then return true. So this, what you're seeing right here is basically just a pass through, right? So you're saying I have my input channel and my output channel. For all of the input channel data, just put it on the output channel. So this is the bare minimum without actually doing any processing. I was gonna do this, but you might not be able to hear it. If you do want to check it out, look up Audio DSP Playground, and it'll show you some of the things that you can do in there, right? For like a sine wave, you can go and use like math.sine on the data that's coming in here, and it'll turn it into noises. So it's a lot of fun. But what I did was I decided I wanted to put Autotune in the browser. I thought that was pretty fun. So I'm going to just run through how I did that. This is not. So there's an open source library called Autotalent, right? And this is an open source Autotune library that is written in C. So here we have this method. You have your initialization methods, and then here I have process samples. That's this method. So at the end of the day, you really kind of want to hook this up to the worklet so that Autotune will work, right? So the problem is that it's written in C. Thankfully, we have Mscripting, and I was able to convert it to WASM, right? So now this is WebAssembly, which will run in our browser, and that I can use in a worklet. So if we just look at how this works for a second, this is just a little bit of state here based around the analyzer. So you get your audio context, like I was saying before, more analyzer code. We add the worklet here, our buffer processor. And then in here, we create our new audio worklet. And the actual worklet itself, which I'll show in a second, is a ring buffer processor. So what happens is the Autotalent expects a certain buffer size to be working with, and the web is not that, right? So what we do is we create a ring buffer, and that kind of provides it properly to be processed, right? So in here, we have all the connection to the destination here, right? This is we're getting our input is from the microphone, and then it's gonna just come through. It's gonna connect. We're gonna got the channel merger, so our live in our microphone gets connected to our Autotune worklet, which then gets connected to the analyzer, which then goes to the output. I know it's a lot. I can't even say it. But yeah, if we look in here, this is our ring buffer worklet processor, where we do import our module here, right? This is our actual C Autotune WASM. So then we have this heap audio buffer where we pass that in, and our process method. So we have our input ring buffer, and this is the piece right here, this .kernel.process, which is what's making the magic happen. So when I'm talking into the microphone, it's creating all these numbers and inputs. They come in, they go into this WASM module, and then gets assigned to the outputs. It's pushed onto here, and then returned, which lets us process audio in real time. So I am going to attempt to get this to work here on Zoom. So you might not hear me for a second. I can't sing it all, but it should be auto-tuning. I don't know. I think it worked. Maybe. Okay. Just make sure I'm unmuted. Yeah. Okay. That worked. Soon. And it shows you, you can take regular libraries that are written in C, compile them to WASM, and have them process real-time audio in the browser. Who'da thunk? So there's another one that is, I guess more of a toy, but really fun for me, and that's the Web Bluetooth API. So this lets you connect to nearby Bluetooth devices, and you can read data from them, and more importantly, you can send data to them. So normally with like Bluetooth, right, like you go and I don't know, you have like headphones or something like that, or you can connect to like your thermostat or whatever. I don't know. There's a lot of like Internet of Things, um, but I'm uniquely interested in robotics, and that's something that you can do. So I just want to show how that works for a second. How you can send data over Bluetooth here. So in here you could say navigator Bluetooth request device, right? And then it gives you your device, and then you get these things called the service and characteristics, which it's a kind of like the port that you're sending it on, sort of. And then you can do this thing called characteristic write value, right? And then new text encoder encode data. It has to be text encoded. It has to be sent. It needs to be an array buffer to make it over. But this is how you can send data over Bluetooth, right? And this was pretty cool. I don't know if this is going to open up. Oh yeah, the tweet's unavailable. That's great. But yeah, I had built a crossbow that was controllable by an app on my phone, by using Web Bluetooth. So I thought that was pretty awesome. Another thing that's cool is Web MIDI. If you're not familiar with MIDI, it's musical instrument digital interface, and it's how you get keyboards and other controllers to talk to computers to control music, right? And they can also control each other over the MIDI format. But I digress. It's a format that lets computers and hardwares communicate with one each other. So normally, right, you have these MIDI cables here, right? These are MIDI inputs, and like if you had the one machine, you could put a cable to here, and it's going to send that data over to this one. And this is what that data looks like, right? You have your note on, you have your data byte, which is like your note number, and your velocity, right? So like this is like, is it being pressed or not? This one is like which key on the piano is being pressed, and this one is how loud is it being pressed. So you can access this in your browser. You can say navigator request MIDI access, then right, and then you're gonna have your inputs.values, and in here you can just set up a listener, right? So I say, there's only gonna be one input for me, so I say input on MIDI message. We call our get MIDI message here. Sorry, so get MIDI message. I say let type note velocity, right? That's an array destructure. Right, that's those three things I just showed before, equals message.data. And I can't demo it here because it's virtual, but I built this MIDI controller to control things in the web. So I actually had some really shoddily built DJ software that I built, where these arcade buttons would control different parts of the song, so you could like do different cue points in your song by pressing the arcade buttons like you were playing Tekken or something. This was the hardest thing I've ever built in my entire life. Quick story about this: it was bananas. So I said to myself, right, I want to make this thing with the arcade buttons, and you hook it up to an Arduino, and it works, and you're like, oh, that's great. Okay, let's like make it like real, right? So you got to create a box for it, right? So I go and I got like a project enclosure, and you'd be shocked how hard it is to actually drill the right size holes into the box. I kept trying, and the boxes kept breaking. The buttons weren't fitting. I was like, "What is going on?" I'm like, I must have ruined 5 boxes, and I had a presentation coming up. So someone suggested 3D printing it, and what you are seeing here is a 3D printed enclosure. And I'll tell you what, it worked perfectly the first time. I went, printed it out, popped these arcade buttons in, and they popped in perfect. The thing still works. It's still sturdy. It is not broken. Um, so wow, what a journey that was. Um, so now that we look through all that stuff, which are all really fun features. Some of them are more for play. Some of them can be directly applied to the work you're doing. I want to talk about some future features. Not to say some of them aren't, like Offscreen Canvas, I guess, is not fully supported yet. Um, but I want to talk about some things that are either coming soon or are being proposed at the moment, um, that are really going to fill in the gaps for me as an application developer, where I'm going to be comfortable building almost whatever I want on the web. Um, Along the way, uh, you know, every single time somebody makes a really impressive app on the web, it it almost sets a bad example, because now that you know that it can be done, now your company wants you to do it, which is, it's a little, because you're like, well, that was like, a team of like 300 people. They made AutoCAD work in the browser. Like, that doesn't mean that we can do this. But, it stretches the possibilities. And I think that the next couple features that I'm going to show are going to be the next step to, our bosses asking us to build unreasonable things. Is going to be great. So the first one isn't too bananas, right? But it's really helpful, and that's native lazy loading. I don't know if anybody's seen this yet, or trying to. You can do it now. It's out. At least in most, it's not on Safari, but who's surprised? Um, but native lazy loading, where you just add the loading attribute, right, to your resources, and they won't load until they're in the frame, right? Which historically has taken so much code to do, and it's been so annoying. Um, but now, this progressive loading is just built in, and while it's simple and it's just one thing, I think it can make a big difference, because at least in the stuff that I do, um, every little bit counts for getting that first page render. Um, so anything that you can defer until later on is excellent in my book, and I'll leave that there. Um, the next thing is a feature called display locking, which I'm very excited about. So you can look here on the WICG group page for display locking. Um, uh, Completely wild. Essentially, you're going to have this content visibility. This might not be what it'll be, but this is the idea behind it. Um, Normally, when you have a really long list, like a virtualized list, you virtualize it, because if you have a list of 20,000 things, and you have all those things in the list at the same time, your app slows down because it's rendering 20,000 things, right? So you use something like React Virtualized, or Iron List, or whatever you're going to do, and it will only render the stuff that should be shown based upon the scroll position, right? It's great. Everything's nice and fast, but it's not great. And I'll tell you why. Because it's literally only rendering the things that are shown. Um, right? That's the point. But the problem is that if you try and have any kind of content discoverability, or SEO, or whatever you want to call it, around that, right? Or you want to hit find on the page, the elements literally aren't there to find, right? So while virtualized lists are very helpful for performance, it's a little rough as far as like accessibility is concerned and discoverability. So what this will do, the idea behind this is that it'll do the same thing, but the data will still be there, right? It's just the browser will just say, you know, literally don't render those in this area where where it's pseudo virtualized. Like they'll still be there in like the searchable tree, so to say. But it's not part of like the paint or memory or whatever, however that works. I don't know. I'm no scientist. But this should be a really exciting feature for web performance moving forward. Um, Another one is portals. Um, if you haven't seen those are like really, really rowdy new edition iframes, um, where you can have external resources pop out and do these kind of page transitions. Like this is like a different URL, but it's as a it's living in this portal inside of your page, right? So again, with web apps not feeling native, this is going to be a big one that makes them feel unbelievably native, right? It's one of these patterns that you see on mobile that we can't really replicate that well right now on web um, until now. Now we can. So I think that's uniquely exciting. Um, and the last one, perhaps the biggest one, is the native file system. If you come over to the WICG again, right, there's a proposal for the native file system API where you can open a file to read, edit, save. Um, you know, this is half the reason I've ever used Electron is just for access to be able to do these kind of things. And now it could just run right there in the browser. Um, Unbelievable. So yeah, back to these right here. These are four really big steps towards a much more app friendly web, in my opinion. And that is all I have. Thanks so much.
This is literally amazing. I'm very impressed by portals. It looks like
That's wild, right?
very cool feature. Yeah, exactly. So let's go to QA session, and we have few questions from our listeners. First one, what's the best place to keep up to date on new web API drops?
Oh, well, you can follow the WICG GitHub, and I'd also recommend following some of the Chrome team, like Adi Osmani. You can see a lot of the fun stuff there.
All fun features announced in Twitter. Yeah,
Yeah.
yeah. Other things what were designed not for the web. Uh, how do you think why browsers become varied machines what do unrelated stuff unrelated to markup? Why we took this direction?
Um, like I said before, I think someone did, and then once you see that somebody can, then they want you to. You know what I mean? Like, you know, if somebody's built, even if it's not on the right platform, the fact that they did it on the web, that it's possible, I think that then that sets a precedent where now it's possible. So a company might say, "Hey, I've seen it done. I know it can be done. So do it." And then essentially you double down, and while it might not be the right choice, it's what I'll tell you what. I show up to work. They tell me to build something. Hey, you pay me. I'll build whatever you want.
Yes, I have a strong feeling what these new APIs will bring more frameworks for us because This is like a low-level design, and we need some more libraries and library wrappers to get more convenient API for developers without any corner cases, with wider browser support, without prefixes or such. I have a question related to Paint Worklet. How it's working with high DPI displays? Do we need to multiply giving size value or such?
I've never actually looked into that. Because yeah, when you work with regular canvas, you absolutely do need to do that. But I don't know about a paint worklet. I mean, I'm gonna assume no, just because I've done it on a MacBook Pro with a Retina screen, and it didn't look off. But I can't say definitively no. That's an excellent question. Though I'm gonna say probably no because no, maybe not because you'd have to you could call ctx.scale on the context.
But
Huh.
do we have these scale values inside Worker? It's kind of not main thread or such. Or
Well, I mean, you're communicating with the worklet, so you could pass it in as a parameter. You could
oh
get
yeah,
that, and then you could pass it in as a parameter, and then do to your ctx.scale. But I don't know about the actual canvas scaling, how that would work, because it's usually like a two-part deal.
okay. And the next question related to audio worklets. Is it possible to use any GPU calculations inside the audio worklet to get something like NVIDIA RTX voice or such, machine learning noise cancellation in browser or such?
Um, I think so. I know that they were doing that for the machine learning stuff. So I don't see why you couldn't run it within there. You certainly have access. Um, and again, it's one of those things that works really good with integers. Like if it like the reason that we don't have like React and everything in WASM completely is because of the transfer cost, right? If you have like a huge tree of React or markup in there and you're trying to pass it back, right? It has to be serialized. Everything needs to be serialized, so you get dinged on the serialization cost. But when you're dealing with just numbers, right? Like it is lightning fast. And audio processing is one of those areas where it makes a lot of sense. It's really well suited for that, and the GPU as well.
Yeah, I was scared because, as I understand, the worklet working in separate thread like web worker or not.
Hmm.
Because I'm not quite sure how we will divide GPU between different threads in JavaScript.
Interesting.
Yeah, and next one question. What is the most amazing thing you saw made using these new fancy APIs?
What's the most amazing thing that I did?
Yes, you did or you saw with all these fancy APIs. Maybe some code
Oh,
pens you can recommend or such.
so a lot of like the Unity and the browser stuff blows my mind. I know that they do that with WebGL and Wasm, and you see like Xbox quality video games in the browser. You're like, what is going on right now? Like, that's so far beyond my pay grade. Like, like I can do some things, but right, like that's like out of control. I see that, I'm like, whoa, that is bananas. Yeah, so I've seen that, and then I'm trying to remember what it was, but there's like a it was like Wasm and WebGL. It was water simulation, and I was like, that is next level. That's like math doctorate shit. That's like
Yeah, water simulation is really hard and nice to get it working smoothly in web. Uh, do you see the web as an answer to the sad state of native App Store platforms like Windows App Store or such? Will web replace it to kind of single point of contact for any application?
um It's hard to say. I mean, as it stands right now, no. Um, Native apps are generally still better. But it's one of those things where the web has an opportunity because it is truly cross-platform, right? Windows, Mac, Linux, whatever you want to do, completely cross-platform. Um, so if it were to mature into a first-class application platform, um, yeah, it would be perfect. Um, but it might not and probably won't. So there might be a new thing, right? There might be a more app-centric thing. You saw Android do it with instant apps. You saw Apple's thing that they came out with in the last week. I mean, the
Yeah,
writing is definitely on the wall, and so like native apps are great and they feel really good, but it is almost impossible to get people to install them. So the
yeah.
discoverability is really really low. And you see the web getting appier, and you see the apps getting webbier and more instant. And the writing's on the wall. It's just who's going to win the race.
Yeah, we'll see in future. I
We
have a
sure will.
question. Yeah, I have a question related to Web Bluetooth API. Any usable tools to debug it? Because we could discover such primary service characteristics list and such, and maybe you could share some documentation or tools to just dig it into it. Because I also just checked it, and it's quite a lot of hash-like data and such, and maybe any usable things to get
So
familiar
when
with
I've used
before
it,
use it.
so it's absolute. If you have a problem, much like Wasm, it's an unbelievable pain in the ass to debug. Um, but when the general communication channel's working, or even in the initialization steps, it's pretty debuggable. At each part of those things where you're getting the device, you're getting the characteristics, you can just log out the available options, and then you can see what you're working with. And then usually, like the Bluetooth thing that you're connecting to, there'll be a spec sheet for that'll tell you, what the different services are, the characteristics that are available. So for my example, when I did the crossbow, I used an HM10 low energy Bluetooth module. I think it's HM10. I digress, but that came with a spec sheet. And you hook it up to the TX RX or whatever on the chip, and then you put that into the Arduino. So what I was doing was on my website, I would console log out each step to make sure that we're connecting properly and that I'm connected to the right thing. Um, and then on the Arduino side, I had a debugger running with Arduino code or C or whatever that is, Arduino C.
Yeah, yeah.
Um, so I would look at the serial logger on there, and then also like the Arduino logs to see if it was coming through. Um, I had a problem for a while because the communications never made it, and I realized that I had to on my side, right? The Web Bluetooth API doesn't convert your data to an array buffer. So you have to manually convert it to an array buffer before you send it. And then once I converted it to an array buffer using the text encoder, um, that's when it finally made it over.
Okay, yeah, got it. I have a question related to native file system API. Is it support streams? For example, could we read some log file what has constantly adding new lines from some application or such?
Um, that's a good question. Um, I don't see anything in here. It's still very early, so I'm not sure if you actually get a buffer or what, or if you just get the entire file. It looks like there's a get file method. Hmm.
so we can't transcode some large dozens of gigabytes files in a browser.
So it does look like you get a stream, and yeah, you can you yeah. There's a file system writable stream interface. This is so early though that I wouldn't I wouldn't say you can or can't do anything. But it does look like the architecture does support streams here, and you have you have like byte cursors and stuff like that. So um, yeah, it looks like that's being accounted for.
Okay. And next question related to display logging. Is it a CSS property? Is it possible to integrate it into modern framework to prevent kind of double work on virtualization, browser work and JavaScript work inside framework? It's not quite clear to me how we would use it. It's just CSS property we need to add to get this list virtualized.
So when I first saw display locking, um, it looked like more JavaScripty.
Yeah.
But now I'm looking at this proposal and I'm seeing the CSS property. Um, I imagine you'll probably have a little bit of both. In Chrome 85 and like two versions, we'll actually get to try it. But I would guess that anytime you had a list that was virtualized, the wrapper around said list, if you just did that property, um, that anything inside of there that wasn't within the bounds of that element wouldn't be subject to that rendering paint cost that you would see.
Okay.
So I think that um, have you used React Virtualized before?
Not, but I used some virtualized implementations for our frameworks.
Yeah, I mean I've used that. I've used some other ones, and they're usually pretty big. And
Yes, it's quite a lot of
uh,
calculations because we need to add node to measure its sizes, and it's mess up once we have nodes with different sizes, and it's
you
completely
get the whole thing
rattled.
with the height changes. It's a shit show. And then if you have like different like if you have like different size things, like different height items in there, right? Then that slows it down by like a factor. Um,
Yes,
so yeah, I
and
think we'll
quite
see. Yeah, I mean, it just seems like a really easy way to fix all that really quickly.
hope so. uh, Nick said the Undefined podcast with Ken and Jared Palmer is awesome. Awesome, good job. So
we
next question. Yeah. How you figure out thems to talk in podcasts?
say it again.
How you choose thems to discuss in podcasts? It's just things you see in work or such, or in inspiration.
Yeah, I mean uh in the podcast we'll just it's pretty free form, so it's like whatever we're excited about at the given time. If we have a guest, we'll usually talk about like something with them that's like, I mean, we often do have a guest, but like, for example, we had like Zach Argyle, Adam Argyle on. I always do that. That's like the fifth time I've done that. But we had Adam Argyle on, right? And so obviously, right, we talked about CSS and the future of CSS. If I had Zach Argyle on, I'd talk about hair products. He's got a beautiful haircut. But if so, sometimes we had like some React team members, and we'll talk about React. I remember we had Joel Hooks on, and we were talking about like e-learning. That was fun. We got some episodes coming back soon. We took a little break there. We experimented with going live rather than like edited podcast episodes. So we were doing like live on Twitter, live on Periscope, and
Oh, it's
it was
really cool.
okay. We did a couple of those, and it was okay. I don't like going live, in case you say the wrong thing. You can't edit it
Yeah.
out. But
But live discussions actually is more interesting, especially for our Corona case, because people need more live, more real people, real discussions.
very much
Next
so.
one question related to lazy loading. Will it work for autoplayed videos? As I understand, now we can autoplay muted videos on web. And will it work for videos if we have kind of list of videos like Cube or such or Wine?
I am not. Let me check on videos because I know that right now it's non-standard to do it for iframes, which would be really the implications for that on iframes and on ad banners and stuff like that. That'll be huge. But I'm only seeing um image examples. I'm not sure if it'll work for videos. You put your video in an iframe, it will. Yeah, I'd have to look more into that.
Okay. And next one, just like for discussion, virtualized list views and Offscreen Canvas. Will it be a good replacement for React Native for a kind of web applications? Because main issues what in React Native related to scroll behavior and such, and if we have smooth scroll with some off-screen calculations and virtualized lists, will it bring us more native experience from web applications?
I think so. I absolutely think so. I mean, so I work in finance, so I make like trading dashboards, and big lists of stuff is arguably the hardest problem. I work on a lot of web apps, and there's also a lot of native apps, and the native apps do way better with like data grids and big lists of things. So I mean that's one of the primary pain points, and if that's solved, then um there won't be much that that's noticeably different. Right now, if you have a big list of things, it's noticeably different. A lot of the virtualization solutions, when you're scrolling, right, it'll do gapping, right, where you'll see like white or blank
Yeah, yeah.
areas in the scrolling and everything like that. And it's like a dead giveaway, right? And it'll drop below 60 frames per second. I think if that's fixed, then it's going to be real smooth and indistinguishable for everybody. They'll be, oh wow, look at this. But
It will be
we'll see.
more amazing. Yeah, it will be most exciting part in modern web once we get smooth long lists to scroll.
Right now, I solve it with Canvas.
Yeah.
Anywhere we have
Canvas,
a
you
big
mean
list,
render items by Canvas?
yeah, I render things with Canvas.
And do you have any kind of things to solve? How you will support accessibility for such things? Just adding additional DOM node near the user cursor or such, or we totally use accessibility with Canvas on large lists?
You pretty. I mean, there's not really a good 100% accessibility story.
Yeah.
Um, for an internal purpose-built application, that's a little bit more acceptable, I guess. But if you were to make this like a public thing, right, where people would just go to it, you probably wouldn't do that because it's not it's pretty much not accessible at all. I mean, there are things that you can do, but it's not great. And it's also, it's on a thing by thing basis, right? Like a data grid, like you could probably pull it off, but like a data visualization, eh. Like this is why you don't, like I think maybe for a data grid, you might be able to get away with it, but probably not still. For a visualization, sure, but like if you're just trying to do like Instagram in the browser and you made it all canvas, Yeah, that's not going to fly. That's zero accessibility.
Yeah. And I have one UX question. Large tables with dozens of columns and rows, is it a UX issue or real use case?
That's a real use case. That requirement exists.
Yes, but could we solve it in different ways? Why we showing a user table with kind of 10,000 of rows? User can't read 10,000. It will try to filter it, search for it, or such. Do we really need to support such huge things in web?
I generally agree with that sentiment that that having something that much is a design flaw inherently. Um, but also, it's we've messed around with like having like conditional columns and things like that, and selecting all your own columns. And a lot of the time, the users didn't feel like doing any of that. They just wanted the big one, just because they knew where their thing was and they can get to it if they wanted to. You know, it, Providing searchability in there. So if you go and you type in a thing, right, it'll scroll to the column that's named
Yeah,
that, or you put in stuff like that. So yeah, I think most of the time it's absolutely something that you could solve with a better UX story, but some of the time it is a valid requirement.
yeah, especially if you're building something like Web Excel or such,
Yeah,
web
yeah, yeah.
spreadsheets.
Excel. I think Excel is like pretty much all Canvas. Not Excel, but Google Drive Sheets.
Yeah.
I think that's pretty much all Canvas.
Yeah, likely. And we have one more question. Hello, Ken. First of all, thanks for your amazing presentation. And question related to Sound API. Call me a dreamer, but do you think it will be possible soon to create a platform for online jam of musicians, free or more, which would have an opportunity to make a jam, mostly MIDI devices, I think, in real time via their browsers?
I think so. Um, I have done a number of web audio experiments that I'm feeling increasingly better about. Right now with Audio Worklet, it's very finicky where you might get like crackling and shit like that going on. Um, but as time goes on, like back when I first started doing web audio stuff, it was not super powerful, but you could build really cool things. I very recently built another kind of like like a FL Studio kind of thing. Like you make like a beat making program. I built one of those in the browser, and it felt pretty good. Um, as far as like the live audio sources and triggering MIDI remotely, it's all possible. It's gonna have to take some iteration, right? Like you could put it together. I don't want to say quickly, but you could put something like that together, a prototype pretty easily. Um, as far as making it performant, that's going to be that's a trek. You're gonna have to really iterate on that, and kind of like what I do with the finance stuff right now, where it's like you get the proof of concept up, and then it's just micro optimization of performance all over the place to make sure that it'll run properly. Because when you have that heavy of stuff going on, just really little things can throw the whole thing off. Like I had a thing just today where we have this like super optimized UI, right? It's like super fast, everything like that. And there was like one of like those shelves, like the panel that comes out with like notifications on it, right? And it turns out that the notifications weren't virtualized, right? So if a bunch of them got thrown, right, you could have like 800 notifications in the list, right? And that ground the whole thing to a halt over a dumb thing like notifications, right? So the hard part is as it scales in complexity, you know, minding that the performance aspect, because some little thing, right, will just creep in and
Interesting stuff. I think this is the last question for our stream part, and next we could move to the Zoom session. Yeah, last quick question. Today in 2020, is some real use cases for Flash exists, maybe in finance or such?
yeah, I think I think Flash. I mean, I haven't worked it in a while, but if they made like a modern Flash and put it in the browser, I'd probably use it. It'd probably be a lot better than trying to build certain things in the web, right? Like if you think like Flash is compiled for one, two has its own layout, right? So it's like everything is pretty much absolutely positioned. So and it's a great authoring experience, but aside from that, right? Like the web itself, the layout system is based around text. So you put a new heading here, everything else moves down, right? It's supposed to wrap around images and everything like that, and it's all set up for everything on the page to be relative to one another in this kind of system. Whereas that's not usually the story in apps outside of rich text areas. A lot of the time you might want a little bit more explicit control, and you don't want what are the side effects of having the relative layout system.
Okay, guys, Ken, thank you very much for very informative talk. Thank you, Alexander and Ken, for very thoughtful discussion. It was very interesting. Okay, so below Alexander, right now on the left of me and on the right of you, there is a link to the Zoom. So somewhere here, somewhere here, the link to the Zoom, and you will meet their people in 2 minutes probably. Okay.
Yes,
Guys,
sure.
thank you very much. I hope your discussion in Zoom will be also so productive as here. I hope that people have any questions. Thank you very much, and see you.
See you.
Bye.
Thank you.